Hello and welcome to Sunday's edition of Cracking the Cryptic. Now, a couple of days ago on the channel, I did a lovely arrow Sudoku, which many of you seem to really enjoy, as did I. So today I've decided to do another one. This is by the doyen of the Discord server, Eric Fox, one of our moderators over there. Eric has become prolific both in terms of setting puzzles and solving puzzles. And yeah, his puzzles are always incredibly clever, so you take them on with a slight degree of trepidation. Now this one, unlike Nichant's puzzle the other day, has a couple of extra twists. Firstly, if you look at the grid here, I mean, basically it's basic arrow rules. So what that means is the sum of the digits along an arrow. So let's look at this one, for example. This arrow here, these three cells have to sum up to what you put in the circled area from which the arrow sort of originates. But here you can see that there are some 2-cell totals. So, you know, if this was, I don't know, 22 and 8, that would mean that this total here had to be 28. It's not 2 plus 8, it's read as 28. The other thing Eric's done, as you can see, is that he seems to have taken great delight in overlapping arrows with totals all over the place. So this might take a while to get to grips with. It's supposed to be extremely good, this puzzle, and not monstrously hard. Certainly not approachably hard, if you know what I mean. So do have a go. With that, I don't think I've got anything else to tell you today, so we'll get straight into it. Let's get cracking and see how we do. Of course, if you want to play the puzzle, the way to play it is to click the link under the video. Now, how do we do this? So let's start with this circle, just because it's where my eyes have fallen. You can see that's got a 3-cell arrow sort of leaving it. So this square here cannot be, because these 3 cells are all in the same box, they must all contain different digits. So the minimum I can make 3 different digits add up to is 6. So this square here must be 6 or higher. Now this cell, look, is interesting because this box here is containing the sum of those 3 cells, because they're the cells that the sort of arrows cover. So this cell, I mean, I could make those actually add up to 20, couldn't I? Because I could, if they were 7, 8 and 9, that would be 24. So this square has to be a 1 or a 2. I was thinking maybe it only had to be a 1, but it could be a 1 or a 2. Now there's all sorts of interplay going on here. So we've got this arrow is summing up these 2 squares and these 3 squares. So again, I'm looking at the tens digit and I'm wondering what that can be. If I make those as big as possible, that would be 7, 8 and 9. So that's 24. Let's make this a 9. That's 33. Right, so okay. So we can't, this digit has to be a 1, 2 or a 3, I think. It can't be a 4. And I think it still could easily be a 1. If these were, say, 1, 2, 3, 4, 5, there would be nothing to prevent that. So, yeah, that would still work if the 1 was here. Yeah, I mean, certainly it does feel to me like there are combinations that would work that would have a tens digit that's a 1 here. So we've got a 1, 2, 3, a 1 or a 2. This one there, no, that's no good. This one, look, is only summing 2 cells. So even though those 2 cells are then summing those 5 cells, actually maybe this square then. Let's look at this square. So this square is the tens digit for the sum of those 5 cells. And those 5 cells are in the same box. So we know that these could add up to as little as 15 or as much as 35. If we put 5, 6, 7, 8, 9 in there, we would get 35, which means this square is 1, 2 or 3. This is just summing 2 cells. This one is identical in terms of sort of the thinking, or at least my thinking, to this one. It's summing 3 cells in the same box, so that's got to be 6, 7, 8 or 9. This one, this digit here, this is a 2-cell sum, and this can't be greater than 2 because again it's summing 3 cells. This one is a useless one. Now I've got these funny ones here. So this one is summing... this one is important. This one is summing these 3 cells. But this cell can't be higher than 3. So even if I make those 2 cells as high as possible, make these 8 and 9, 8 and 9 and 3 is 20, which I can't put into the total because I can't use 0. Not actually in the new software, so even if I wanted to use 0, I couldn't today. But obviously we can't put 0 in a Sudoku. So this square actually has to be a 1. It can't be a 2 because I can't make this sum to 20 in any way that allows me to place the units digit, which means this is not a 1. And then we've got this one, and this is the big arrow as well. So we've got 1, 2, 3, 4. It's not actually that big. I thought it looks big because it's got 2 diagonal slants in it, but it's actually only summing 5 cells, 4 of which are in the same row. So if I make these 4 as big as possible, yeah, okay, this is quite useful. If I make those 4 as big as possible, they would be 6, 7, 8, and 9. Let's add another 9 in there for good measure. We still don't get to 40. So this square has got to be 1, well, it can't be 1 now, so it's got to be 2 or 3. So there's a 2, 3 pair in box 4. Now, it'd be more useful if this 2, 3 was here, then I'd get this digit. Sorry, this is the standard hiatus where I get stuck. Not sure. There's an incredible amount of overlap between all of these sort of arrows and sums here, but I'm not actually sure I can do much more here. I have got 1 digit in the grid, so I'm not doing terribly badly. Oh no, hang on. There are 8 cells in box 2 that are... Oh no, I was thinking I could put a 9 into this box by putting it here, because I was forgetting. In normal arrow Sudoku, you don't have these 2-digit totals, so you can never put a 9 on an arrow. But here, I can put 9s on arrows, of course. Oh, now, although, yes, this is good. I can limit this one, because this total here can't be that big. It can be a maximum of 9. So if I make that 9, and I make that as big as possible, so let's make this cell 9. If I make these 3 add up to 9 and make this a 9, that's 18. Which means these squares have to add up to a minimum of 45 minus 18, which is 27. Now, why do I get 45? Well, it's the standard thing. If you watch this channel, you'll be bored to death of me saying this, but we always pick up new subscribers, so I never know who's watching. If you add up all of the digits in any box, in any row, or in any column of a Sudoku, you obviously are going to be adding the digits 1 to 9 up. If you add those digits up, you get 45. So I know this box adds to 45, and I know the maximum size of those squares is 18, so I know the minimum size of these squares is 27. That means that square can't be a 1. And that gives me a 2-3 pair now here, which might be useful. Maybe. What's this doing? Why is this important? Maybe it's not important. Maybe we can get more of a restriction in this box somehow. So if this has got to be Ah, no, hang on. Right, I'm just thinking about this. If these cells have to add up to at least 27, this cell is interesting all of a sudden, because this cell would work if this was 27, but it wouldn't work. This cell would be impossible if this was 28 or 29, because that square would then have to be 10 or 11, and that's not possible. So either this is 27 or it's a number greater than 30. So it's 31 to 35. It can't be 31, actually, there's a 1 here. So this is quite restricted. Oh, this is extremely clever. This is extremely clever and absolutely deliberate. I've just spotted what's going on here. Right, we need to think about this. Is this 27? This is the key to the puzzle, or at least this bit of the puzzle, because the answer is no. I had thought this was possible, but it's not. Why is it not? Well, we need to think about what it does to this box to make this 27. There's only one way we can make this 27, and that's if we make these squares add up to 18. I've said we've already looked at this, but I didn't think it through enough. If these four squares add up to 18, the only way of doing that is with a 9 here and some cells here that add up to 9, which makes this a 9. But what do 2 and 7 add up to? Yep, 9. So you get 9s repeating in row 4, and that does not work. And therefore, I don't think this square can be a 2, because if it's a 2, we've just shown 27 fails. If it's less than 27, we can't make these squares high enough. And if it's greater than 27, 28 and 20 or 29 break this single cell total. So this has to be a 3, and this square now has to be 2, 4 or 5, because it can't be 1 or 3. And therefore this square has to be 5, 7 or 8, none of which unfortunately are ruled out by this. So this square's a 2 now, obviously, because of the... But that square's a 3. This square is a 3 now. And this is the sum of these ones. So this now is quite restricted as well, because this square... In fact, this is again very restricted, and I suspect deliberately so, because this cell, look, can't be a 1, 2 or a 3 now. So how on earth do we get... Let's put a couple of... I'm not sure we can get higher than 35 here. If this was 7, 8, 9, that would be 24. 25, 26, 35. Okay, yeah, so 35 is the maximum. So if this is 7, 8, 9, this has to add up to at least 10. It's got to be 10 or 11. But that, this again, I think, this is really clever again. This is really clever again, because I think we're going to be able to eliminate 2 from this square. Because if I know that I need this total, or the digits in here to add up to at least 10, then if I use 2 in this position, this square has got to be equal to 8 or 9. And that's all very well, except that this is a 3-digit total, so that you can never make this higher than 2, 4 here. And 2, 4 only adds up to 6, which is no way enough to get us anywhere near 34, even if I make that absolutely maximal. So this square is a 1, and that puts further pressure on this sum. In fact, this finishes the sum, because now how on earth do I even get to 34 as a total? You know, I can just do it. If I make these all as big as possible, I've now got 24 here, 25. I still need 9 more, and I can. That's the biggest number you can put in a Sudoku. Things you learn on cracking the cryptic. This has to be a 9. This is now 19. So these 3 cells are summing to 19. This is not a 9, and this puzzle is very, very clever. Now, don't get stuck here. This puzzle is very clever. It's incredibly linear as well. So I think you guys are going to write in the comments and tell me all the things I've missed. I now know as a result of what I'm about to say. But it does feel to me like I've been led on a very specific path here. And, you know, the sort of logic here took me down here, which has taken me here. And I've just noticed that once we get the 9 here, this square can't be a 9. So these 3 squares now have to include, you've guessed it, a 1. Because the 3 cell sum adding to 6, 7 or 8 always needs a 1. There's a 1 here, so the 1 in fact is placeable. 1 goes in the bottom of the grid. These squares here have got to be from 2, 3, 4 and 5. 1 is quite restricted in this box now. It's got to be in one of those 2 cells. No, it is absolutely deliberate. This 1, look, it's pointing at this triple. So now I can't put a 1 on this triple. But this is a single digit total. So that's got to be 9, because the minimum I could make those 3 squares is 2, 3 and 4, which give me 9, just. So this is 2, 3 and 4. This is not 3 because of the 3 here. So now, yeah, now we've got a problem with this. Yeah, this is totally doable, isn't it? Because if we know, yeah, this is very clever. This is very clever. So whatever we put into this cell here tells us the sum of those 5 cells, which we can add 9 to. So let's try it. If we go 32 here, 32 for those cells, plus 9 is 41. That would make this square a 4. Well, we can't put another 4 in the box. If this is 34, 34 plus 9, yeah, is 43. That would put a 2 here, which clashes in the box. 35 will work, though, because 35 plus 9 is 44, which gives us a 1 here, which gives us a 2 there. This is probably the next place we need to look, but let me just check this. So we've got 35, we've got 5, 6, 7, 8, 9. Oops, let's make sure we put the 9 in as well. Yeah, look, this 3, 5, I nearly missed that as I was staring at it, but this one is the sum of those 2, so that's an 8. This is not 8. 8 must be in one of these 2. 8 must be in one of those 3. There must be a 5 in one of these 2 cells because of this 5 here. There must be a 3 in one of these 2 cells. 1 is placeable here. This one gives us the 1 in the central box. So 1 is down here. Now, let's just come back over here now because, oh, this cell is very restricted. Look, this is a 3 cell total, but we can't put 1 or 2 here, so this has got to be 3 or 4. Now, if it's 23, we know that's 6, 8, 9. If it's 24, it's 7, 8, 9. So this is, so there must be a 5, look now, in one of the, yeah, we've got a 5, 6, 7, 8, 9 quintuple. Now the 5 in that quintuple is definitely in one of those 2 cells, so it's not there. Okay, that's not 2. We've we've got 2, 3 and 4. Oh, sorry. Where does 3 go in row 1? This 3 here is quite powerful. 3 can't go there. So 3 goes here for 2. This must be a 2-4 pair, which we can probably resolve. Maybe. No, maybe not. Famous last words. 4 here the 4 here gives us a 3 here. So this is 6, 8, 9, which means this is not 6, 8, 9. This is 5, 7. Let's remove 7 from all of those. So this is a 6, 8, 9 triple. 2, 4, 3. Where does 2, 4, 3 go in the central box? It's got to go in those 3 squares because these can't be 2, 4 and 3. This is not 2. That's got to be a 2 in here. So we're doing a bit of Sudoku all of a sudden. There's nothing wrong with that. 8. This is interesting. Where does 8 go in box 1? This 8 means it's not in those squares. If it's on the arrow, it now has to be accompanied by at least a 2, which would make this square at least 10, which is impossible. So the 8 must go here. So now in this box we need to put 6, 7 and 9. That can't be 9. Okay, this is quite clever, look. So this can't be 6 now, because if it's 6, this either has to be 8, which it can't be, or it's got to be 10, which it can't be. So this is 7. This now has to be 2. This has to be 4 in order to allow this to be 9, and that is the 6. That gives us a 6 here, and we're cooking with lots and lots of pleasant gas, if there's such a thing. 1, 4, 7 here. Okay, so now can we go further? And get any... I feel like I might have to do some Sudoku down this column. Look, we've got 2, 5 and 7. That's got to be a 5 or a 7. 2, 5 or 7 at the bottom. So there's definitely a 2 at the bottom of column 1. These squares, look, have got to be 5, 6. That's got to be 5 or 6. These two are 5, 6 or 8. So there's an 8 at the bottom of the column. Now this 5, 6 is affecting, is it this total? Yeah, there's the arrowhead there. So it's those 3 that add up to this total here. So at the moment we've got 7. 7 plus 5 would give us 12. So we need 12 or 13. So this is not 4. Where does 9 go in this box? Yeah, 9's just placeable by Sudoku. So this becomes a 7, 8 pair. That, look, the 8's a line in columns 4 and 5. So we've not yet managed to put an 8 into column 6. It can't go in those squares, so it must be in one of those 2 positions. These 3 squares here have got to be 5, 6 and 9. 9 is placed. We get a 5, 6 pair, which I can't immediately see how to resolve. Now, what more can we do here? Can we do anything more? Let us see. We've got to put 7 and 8 at the bottom of this column. We've got... So we've actually done quite well with most of our arrows. We haven't done this arrow yet. I haven't quite done this arrow. This arrow's still got quite a lot of latitude though, which is a bit annoying. I should complete this. Look, there's an 8 there. That can't be 8. So if we come down this column, we need 3, 4, 6 and 7. So this square here, that can't be 3 or 4. That's got to be 6 or 7. So 6, 7 pair in this column. So these are 3 and 4. Be a 5 here. 6. So if this is 6 or 7 here, look, now we can't put a 5 in here anymore, can we? Because, no, we can't, because we know that these two are either summing up to 6 or 5, and we can't repeat the 1. So we can remove 5 as an option. Struggling here. 19 here. Oh, this is good. 19 here, and this is a 3 or a 4. So let's look at this total. If this is a 3, those two have to add up to 16. Well, we've already got a 7 in the box. I can't put 7 and 9 in there. So this is a 4. This is a 3. These add up to 15 now. 7 and 8 is impossible, so these have to be 6 and 9. There's a 6 at the top. So we go 6, 9, 9, 8, 8, 7, 7, 5. 2, 3, 4 triple in this column, so that must be a 5 at the bottom there. No, don't stop. It was going so well, as Q used to say on Star Trek The Next Generation, especially in the pinball machine, if you ever played that. 5. Oh, bobbins. Look, I've got something though. 3 here. So that 3 is pushing a 3 onto this arrow sum. So this now cannot be adding up to 7, because 7 would be 1, 2, 4, and we know there's a 3 in the sum. Very nice. So this has got to be 1, 2, 3. This has got to be 6. No 6 here, therefore. Therefore, this has got to be 6. That's 7. This is 5 by Sudoku. This arrow sum is now done. Look, we've got 13, so this is 3, not 4. I want to make that 3. That's 4, that's 2. That's 2, that's 3, and we are doing well again. 5 gets removed from here, so this becomes 5 here gives us the 5 and the 8, gives us the 8 and the 7. This square, look, has got to be a 4, and that looks like it's working. This 7 gives us the 7 and the 2. So yeah, probably what we need to do now is just put in the options for the rest of this row. So what have we got here? We've got 4, 5, 7. That can't be 5. Here we need 2, 3 and 8. You can see we can do some eliminations. And here we need 1, 6 and 9. Again, we can do an elimination there. Can we do any better? Probably it's this little arrow here that's going to help us finish the puzzle. That's my suspicion. It looks like it's been put in to disambiguate the right hand side. So let's look at this. We need 4, 7, 8 along there. Oh, we've actually got this. This is interesting as well, look, because this is affecting this arrow that I've not finished. So I've got 27 here. I've got 14 in those squares. Those two squares must add up to 13, therefore, to get to 27. We can't put 4 in this square, because that would require a 9 here. That would repeat the 9 in the box. So this is a 7 or an 8. This can't be a 1 or a 2, therefore. This has got to be a 6 or a 5. 5, 6 pair there. So these two squares must be 1 and 2. This arrow is important now, look. You can't put the 4 here, because this would have to be 1 and 3, and it can't be, because 3 is not available as an option there. So the 4 gets placed. This is not 4. And in fact, so this can never be a 4 either. because I can never get to 7 or 8 with a 1 or a 2 there. This is not, this is not 4. There's a 5-7 pair here, so this is 4. This is 4. This must be, I think I'm now missing something that's staring me in the face. This is so frustrating. That can't be 9. Maybe I have to fully pencil mark. Let's do that. So we need 3. Yeah, there you go. That's going to give me 3s, I can see. 3 must go here by Sudoku. 3 must go, yeah, this is important. 3, 3, 3, 8, 2. 2 fixes the 1 here. And the 2 here, but that must be useful for this sum. Yeah, this can't be 5 now because that would need a 6 here. So this is 8, this is 7, this is 5. That gives me 6 here. These have to add to 13, so that must be 7. Fixes the 7 and the 1, gives me a 6 below. The 1 fixes the 1 and the 9. The 9 must go here. This must be 8, this must be 6. This is 6, this is 5. I'm expecting a 5 there. That looks okay. Check. Yes. What a lovely puzzle that is. I love puzzles that take you on a journey. And that, you know, this linear pathway is something you just don't get from computer created puzzles. You get it from the very best constructors. And Eric again shows us that he's one of those. So loved it. Thanks very much, Eric, for sending that to us. I hope you guys enjoyed it. Do let us know in the comments as always, and we'll be back later with another edition. I think Mark's got quite a tough one this evening of Cracking the Cryptic.